Welcome back. This is Mr. Warner. Today we're covering Unit 4.5. So far we've covered how to solve quadratics using factoring, completing the square, quadratic formula. Today we're just bringing it all together and we're going to discuss pros and cons for all of them, and see if I give you a problem, what method would you use? And if you had no idea, let's talk about that and see what works best. Anyways, so when you're given a problem, you should probably do it in this order. Okay, first try and see if you can factor. If you can factor, it may be your fastest way, especially if a equals 1. Factoring is fairly quick. You can use the shortcut and you're good to go. Okay, but if you go to the point where you multiply, let's say you have, let me write this down. So say you had some sort of equation, ax squared plus bx plus c equals 0, and you multiply the first and last term, that would give us ac x squared, and on the bottom you need to add up to give us bx, a times c. And if you can't figure these two things that make this work, then you should probably move forward, okay? Because like I said, not everything is factorable. So give yourself 60 seconds to see if you can find out those two numbers, okay? If not, go ahead, okay? Next is perfect square equations. We talked about that in 4.2, but if you can find something like that, something like this sort of equation where you have, so on one side you have a squared and on the other side you don't, you can just square root both sides and you can solve fairly easy with that, okay? But most of the time, perfect square equations is part of completing the square, okay? And we'll do an example of that as well, okay? Because when we complete the square, we basically force our equation to be a perfect square equation. And that is 4.3, okay? If you can't factor, and we may want to consider completing the square. But completing the square works best, and I would only try and do completing the square when a is 1 and when b is even. Okay, when I talk about a and b, again, we're talking about this at the top. Sorry, it deleted everything. Ax squared plus bx plus c. That's what we're talking about when we're talking about a, b, and c. So if a is 1 and b is even, then completing the square would be a good choice. All right? But if not, then the quadratic formula would be your last choice. It's the last thing on your list, and but it always works. There's lots of chances. There's chances that you're going to get things wrong or put signs where they're not supposed to be, or you forget to put a square root, or there's lots of pitfalls that a lot of students run into with completing or quadratic formula. So just be careful when you do it. Make sure you know the equation. And that's the other thing, is you have to have it memorized. And if you don't know the formula, then it's going to be very difficult to use the quadratic formula. All right, so let's go through some examples. So first example, we have x squared plus 4 equals 4x. Okay, so the first thing always, number one step or thing, is always putting things into standard form. Okay, always. Okay, so here they take it and they put it into standard form. All right, after that, we would need to multiply the first and last term. That would give us 4x squared. We want to find two things that will multiply to give us 4x squared, and add to give us a negative 4x. And the only thing that you can come up with that would be negative 2x minus 2x. Multiply that together, it gives you 4x squared. And if you add those together, it gives us a negative 4x. All right, and since a is 1, we can use our shortcut. You realize that this number is the same as this number, and this number is the same as this number. Okay? If it's a is not 1, then you would need to do grouping. Okay, so remember grouping for the test. Okay, grouping is where we take these two things and we would plug it into the middle, we would cut it in half, and take the GCF of both sides. And okay, if you have any questions about grouping, come and talk to me. All right, so now we have these two parentheses. What we're going to do is we're going to take what's inside of one parenthesis and we're going to set it equal to 0. And then we'll do the same with the other side. Okay, to solve, we have to have x by itself. So we would add 2 to both sides. That would give us 2, x equals 2. And for the right side, we'd do the same thing. Just so happens that they are the same. X equals 2 and x equals 2. All right. If factoring does not work, and your equation is in some sort of form like this, which is not in standard form, okay? If I can recall on the test, everything will be in standard form. So like I said, perfect square equation like this is more of it's like in our step for completing the square. But if you did have something like this, it's all primed to just square root both sides. I guess it's written there below. Don't forget that we have a plus or minus. And then we would need to add 2 to both sides. Would give us this. And then we would divide both sides by 2. And you'd get I plus or minus, or 1 plus or minus I. Okay, so again, completing our perfect square equations will be more like what's in completing the square, and we'll talk about that now. And it says here, notice that the plus or minus sign is inserted in the equation when the square root was taken. So we have to put a plus and minus whenever we square root both sides. Okay, so here's a good example of where we'd want to use completing the square. If you tried to do a factor tree, or like multiplying the first and last term, that would give us a negative 11x squared, and adds to give us 6. Okay, but the only two things that multiplied to give us a negative 11 would be a negative 11 and 1, or 1 and negative 11. But there's no way, if we added those together, there's no way we could get 6, because that would give us negative 10 or positive 10. So there's no way we can do factoring for this problem, equation. That's what I was trying to say. Anyway, so it says it's not factorable. But since a is 1 and b is even, we can use completing the square. All right, so has some part of this how to complete the square, but we'll just do it by doing the problem. Okay, so if we have a problem like this, the first step is to move the constant to the other side. All right, usually when I do this, I would do x squared plus 6x, and I would leave a spot equals 11. Okay, and then to complete the square, the value to complete the square, c equals b over 2 squared. That gives you c. So for our example, b is 6. So 6 over 2, which is 3. 3 squared is 9. So we would need to add 9 to both sides, and that's what they write in here. So they kind of skip this part where you come and find the c that completes the square. Okay, and then they add these two together to give us 20. On the left side, we chose a c value that completes the square, meaning that this trinomial can be written as a binomial squared. It's a perfect square. And that will always be this 3, because it's 3, I don't know what I'm trying to say. What goes in that parenthesis will always be half of b, always. Okay? And if you forget that, you can always do factoring. You could do glasses, you'd get 9x squared, and add up to give us 6x, and it turns out to be 3x plus 3x. You could use the shortcut, so you'd get x plus 3 and x plus 3, which is x plus 3 squared, which is what's right here. So that's what you get when you factor. And it also has to be, since it's a perfect square, that what's in that parenthesis will always be half of b. Sorry, excuse me. All right? Whew. Okay, so after that, now it looks like a perfect square, just like we had up here at the top. We had something with parentheses squared equals something on the other side. Okay, so after that, we would need to take the square root of both sides, and that's what happens in this spot. Maybe not a triangle, let's do a little star. Okay, square root both sides. Don't forget the plus or minus whenever we square root both sides. And then we'd also need to simplify our root. So we could do 2 and 10 and 2 and 5. Groups come out. That's where we have a 2 in the front. And 5 stays inside because it's not in a group. And then we'd finally subtract 3 from both sides. And you get your answer here. Okay, so if you have any questions on that, please let me know. I know completing the square sometimes is a little tricky. And again, the reason why it's called this, we can kind of do an example of this, and I think I did this on 4.4, but just in case you missed that, say we have this, what we have on the side here. Or let's erase this right here. So we move that over so that we can complete the square. Okay, so we moved 11 over, and we want to complete the square. Well, what we have so far, here we would have x squared, okay, and that's a square. You can see that's a square. It would be x times x. That would give us x squared, and that's a perfect square. Okay, but if we add the other term, which right here would be 6 times x, this would give us 6x. If we add those together, that's not a perfect square. It's like a rectangle, okay? And we want it to be a perfect square. We'd want to still have this same x squared. We can't do anything with that x squared. Those lengths of x times x give you x squared. But instead, this time, we're going to cut the middle term into 2 parts. Okay? So here we'd have more like 3 and 3. Because if we add 3x and 3x, it'd still give us 6x. But now our picture looks more like a square, except this square is missing this little part in the corner. And that's what we're talking about when we say complete the square. So what's going to make that work? Well, here, this length right here is 3. You realize this same length would be 3. Or maybe I'll write it on the side. This would be 3, and this would be 3. So the area there would be 9. Okay, so to complete the square, this has to be 9. It would be x squared plus 6x plus 9 makes a perfect square. And then on top of that, to write it as a binomial squared, well, what we're really doing is we're doing x plus 3 times x plus 3. Well, that is just x plus 3 squared. Okay? So that's kind of where the completing the square kind of comes from. That's why, I mean, it's a square, and you can square the sides and blah, 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 or square the area kind of thing. I don't know if that makes sense, but I thought it was kind of cool. Okay? But if you can't complete the square, quadratic formula is what you should do. Okay? If it's not factorable, if it's not a perfect square, and if A is not 1 and B is not even, you're going to want to use the quadratic formula. So just remember, it's right here. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we have that song. If you want to, you can go to, what was it, 4.4, where we went over that. Or you can go to YouTube. There's so many. I heard there's like a 4-part harmony somewhere that was pretty good. Okay, so anyways, go and practice that. Make sure you're good with memorizing that. Write it 10 times without looking. That would help. Do something like that. Okay, so this equation is right here. 2x squared minus x plus 5. Okay, so looking at that first up, you maybe not know if it's factorable, but you would want to do the glasses. You'd get 10x squared. You want to be able to add up to give us a negative x. Okay, the only things that multiply to give us 10 is 1 and 10 and 2 and 5. And there's no way that you're going to get a negative 1 from those. Okay, so can't factor quadratic or complete the square. Okay, well, complete the square, A has to be 1, here it's 2, and B has to be even, and here it's negative 1, which is odd. So we can't complete the square. So let's do the quadratic formula. I always tell you that on your test, part of your point is going to label A, B, and C. So for this example, A is 2, B is a negative 1, and C is 5. Okay, we're going to plug it in. So x equals negative b. So here they kind of simplified that already. It should be a negative b, which is a negative 1, which gives you a positive 1. Plus or minus the square root of b squared minus 4ac all over 2a. Okay? So once you get that, you need to simplify. That's all you have left. First, you're going to simplify the discriminant. So what's inside the root is called the discriminant. So I would plug that into your calculator, or you can do it by hand. So negative 1 squared is just 1. Then we'd subtract 4 times 2, which is 8. This is 8. And then 8 times 3 gives us 40. And they write it down here, okay? Finally got that down to negative 39. Okay, then we need to simplify the root. Okay, well, we have an I. We need to take that out. I always make it be positive, and then put an I. And they did that in the next step. The square root of 39, we can't simplify that. We'd get 3 and 13. Those are both prime, so we don't have a group to take out. But if you did, you would need to take that out. And then the last step would be the fraction. Simplify the fraction. Well, 1/4 is already simplified, and 1 over 14 here would be simplified. Remember, when we do the fractions, they have to all be, integers. Okay, dividing. We're not gonna divide 39 divided by 4. Okay, this is irrational. This is rational. Only thing you could divide is if, I don't know. So just don't ever simplify things like that. Okay, so like another example, if we had another example, something like 2 plus or minus 4 square roots of 3, or no, let's not do 3, or something. Yeah, maybe let's do it like that. Somehow you end up getting something like this, okay? You can't ever simplify those, all right? This would be fine, would be done. We can't simplify. We can't divide 2 by 3. We can't divide 4 by 3. So you really need to look at all three of these numbers and say, what's the greatest common factor? And then you can divide all three of them by that. Okay? All right. So we went over that in class. Probably I didn't go as much detail in class, but anyways. And then I handed out, let's see if I can find that right here, an in-class assignment. Okay? Compare methods for solving quadratics. Okay, and this is part of an in-class assignment, and I didn't allow anyone to take it home. So if you were absent, you're going to need to come and get this from me. Okay? So, and since your assignment for in-class doesn't have any assignments, if you're missing this, then that's going to hurt your grade quite a bit until you get it fixed. All right, so what we're asking you to do is we're going to go, we have a problem, and I want you to go through using all three methods. But again, if you can't factor within 30 seconds or 60 seconds, go on, okay? And I want you to, if it doesn't work, I need you to explain why. So for example, well, I'll talk about that as we go. Okay, so we're just going to go ahead and try to factor. Okay, so one of the things you can do to factor is if it's a difference of squares, that will help us a lot. So let's do it by difference of squares. So we can square root both of these terms. That would give us 3x and 4. Remember, both of the parentheses will have the same thing because it's a difference of squares. 3x plus, or 4, and then one's going to be positive and one's going to be negative. Okay, and then we need to set each of those parentheses to equal to 0, or what's inside those parentheses. So we'll have 3x plus 4 equals 0, and 3x minus 4 is equal to 0. So then to solve, we've got to get x by itself. So subtract 4 from both sides. We get 3x equals negative 4, and then we'll divide both sides by 3. And that would give us x equals negative 4/3. All right? And then the other side, you do the same, plus 4. You probably guess what your other answer would be. Would be a positive 4/3. Okay? And then solving by completing the square. Okay, so again, if you want to complete the square, A has to be 1, and B has to be even. Okay, and here A is not 1. And in fact, B, 0 is not, I don't know. If B is 0, you probably shouldn't do completing the square either. Okay, I mean, yeah. Okay, so we just want to skip this, would say, nope, not going to do it. A is not 1. Okay, quadratic formula, we need to write down our A, B, and C. So A is equal to, so A is 9, B is 0, and C is negative 16. So we do x equals negative b plus or minus the square root of b squared minus, oops, not b, 0 squared minus 4ac all over 2a. And a is, sorry, 9. Okay? So again, use parentheses when you substitute things. Negative 0, that would just doesn't count to anything, that won't affect anything. Same as this 0 squared would just be 0. So we want to first simplify the discriminant. So negative 4, I'll get my calculator. Okay, so please, hopefully you have a test or a calculator by the time you get to the test. I have limited calculators, okay? So you need to make sure that you have one for yourself. Okay. Oh, sorry, that was 16. That's why I'm getting messed up, okay? Negative 16. So it'd be negative 4 times 9 times a negative 16. Yeah, what am I getting? Oh, darn it, again, sorry. Negative 4 times 9 times negative 16. Sorry, I got it wrong. Okay, got it. Okay, so we got plus or minus the square root of 576 over 18. Okay, so I would try and see if it's a perfect square by taking this, putting it in your calculator and do the square root of 576. Okay, and it ends up giving you plus or minus 2418 over 18. If not, you would need to do the same like factor tree. Okay, so like, I don't know, 576 and divide that by, I don't know, 2. 2 and 288. You could divide that again by 2. 2 and 144. Okay, and that's a perfect square would give us 12 and 12. So 12 times 2 gives us 24. Okay, and simplify the fraction would be the last thing, would be 4/3. Okay, and if you look, plus or minus 4/3 is the same as what we have over here, plus or minus 4/3. Okay, and they should be the same. Okay, so I'd like you to go ahead and do 2 and 3. I'm going to go ahead and do this problem. They all work, so I'll just give you another example of how to factor, completing the square, and quadratic formula. Okay, so but I'll require you to do 2 and 3. Okay, so here we want to try and factor, multiply the first and last. Oh yeah, one thing is this is not standard form. Make sure you need to put it into standard form. Same as 2, okay? So it's kind of tricky. If it's not in standard form, you're going to get wrong answers. Okay, 4, so that would give us 15x squared, and you want to add up to give us 8x. Well, it could be 3 and 5. Okay, we can use the shortcut because a equals 1. So x plus 3 and x plus 5 equals 0. And then we need to set each of those equal to 0. So x plus 3 equals to 0. And what's going to make that be 0 is if we have x is negative 3. And then the other one, a lot of this you could probably just figure out, oh, that's just going to be a negative 5. Because if we plug in negative 5, it gives the whole thing 0. So we have x, negative 3, and negative 5. All right, completing the square, x squared plus 8x. Remember, we need to subtract 15 from both sides. So we'd have equals negative 15. We want to find something that's going to complete that square. Okay, to complete the square, it will always be c equals b over 2 squared. So for here, that would be 8 divided by 2 squared, which is 4 squared, which is 16. So we need to add 16 to both sides. On the right side, we just have 1. On the left side, we're going to write it as a binomial squared. Okay, it will always be x, and what goes inside will be half of that, which would be plus 4. Okay, if you don't believe it, you can do glasses, and get that same thing. Or you could distribute it and make sure that works, something like that. Okay, either way, would need to square root both sides, plus or minus. So we'd have x plus 4. Remember, the square root and the square cancel. Okay, and we'd have plus or minus 1. Last step is to subtract the 4 to the other side. So we'd have x, oops, that's a plus. X equals negative 4 plus 1. So that's our two choices, negative 4 plus 1, which gives us a negative 3. And negative 4 minus 1 gives you a negative 5. Okay? And those are the same. And then we do the same if we did the quadratic. So A equals 1, B is 8, and C is 15. So we'd do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? First thing to simplify is the discriminant. So 8 squared is 64. 64. And negative 4 times 15 is negative 60. Okay? And that would give us 4. So we'd have x equals negative 8 plus or minus, well, I guess we'll not split this, so it'll be square root of 4 over 2. And that's the same thing as negative 8 plus or minus 2 over 2. Okay? And then if you wanted to simplify the fraction, we can divide 8 by 2 to give us a negative 4. And 2 divided by 2 is 1. So we'd have negative 4 plus 1 and negative 4 minus 1, which is exactly the same as what we wrote right here. So that would give us x equals negative 3 and negative 5. Alright, so they're all the same. Okay, so again, come and get this from me if you haven't done this, so you can get points. I'd like you to do number 2 and number 3. Okay, alright, we'll see ya.